Today we're going to go from ratio rates, equations, and double number lines to plots on the coordinate plane. A soccer team is traveling by train to a tournament. They're traveling from Yonkers, New York to Morgantown, West Virginia for the tournament. The distance between Yonkers and Morgantown is 400 miles, and the trip will take a total of 8 hours. Here's the train schedule for both leaving Yonkers and leaving Morgantown. We are now asked to create a table to show the time that it will take Kelly and her team to travel from Yonkers to each of the towns listed on the schedule, assuming that the ratio remains the same. Okay, how are we going to do this? What information should we put first? Well, if we are told that the distance between Yonkers and Morgantown is 400 miles, then we can definitely put that in first. And if we know that from Yonkers to Morgantown is a total of 8 hours, then we can plug that in. The last bit of information we know is how far it is to each of these towns, Allentown, Caroline, Berkeley Springs, and so forth, from Yonkers. So we can put Allentown, 100 miles, the next town at 200 miles, the next at 300, until finally we reach our 400. Notice that we have two values. This means we can determine the ratio from this one set of values. Let's do this. Okay, the ratio is 8 hours to every 400 miles. Because we know that every ratio has value, we can turn this into a fraction. And then because I can see that both 8 and 400 can be divided into something, and in this case 4, I'm going to do this. And I find that my new ratio or fraction is 2 100ths. And wait a minute, both of these numbers are even, so I can simplify this even more. I'm going to divide both sides by 2 and come up with 1/50th. And this fraction can now be turned back into a ratio, and I now know that the ratio that is equivalent for every set of values in this table will be 1 hour to every 50 miles. This is great because at 100 miles, I know that that is double the 50 miles, so that means it would be double the 1 hour, giving me a new set of values of, for every 2 hours, we will travel 100 miles. And what about the 200 miles? How many more times is that than 50? 4 times 50 is 200, and so 4 times the amount of 1 hour is 4 hours. And how about 300 miles? That is how many times 50? 6 times 50 is 300, and so 6 times 1 hour is 6 hours. Now we have this table filled in with how many hours and miles it would take to get to the 4 towns after leaving Yonkers. But the question also asks how much time it would take the team to travel back from Morgantown after leaving Yonkers. Well, since I know the distance between each of these towns was 100 miles, I can just go 100 miles back each time from Morgantown, heading backwards to Yonkers. So let's do that. Now I have 500 miles, and that would have taken me back to Berkeley Springs. 600 miles, I would go backwards to Carlisle, I think, Pennsylvania, and so on and so forth. And you know what? I see a pattern in the hours column. 2, 4, 6, 8. And I can just continue that pattern, 10, 12, 14, 16, without having to do much math at all. With all of our values now filled in the table, let's use all of this to represent these distances in hours on a double number line. Okay, now where to start? Well, a double number line has to have 2 different sets of values. What are our 2 different sets of values? Hours and miles. So let's label each of our number lines, hours and the other one miles. And we're going to start at 0 for both. 0 hours is going to be 0 miles. And our first set of values was at 2 hours, we're going to go 100 miles, so we can put that. And obviously we already have our values, and you can see where this is headed, so we're just going to plug in the rest of the values. 2, 4, 6, 8, 10, 12, 14, 16, and miles, 100, 200, 300, 400, and on. Now, why did we do this? Well, let's use this double number line to figure out how many miles they would have traveled in 1 hour. Okay, 1 hour. Well, where is that on our double number line? It's not there, but we know where it would be. So we can point exactly between 0 and 2 and say 1 hour is right there, halfway between 0 and 2. But how many miles is that? We're not told on our double number line. And yet we know that halfway between 0 miles and 100 miles would be 50 miles. Basically, we divided the hours by 2 to get 1 and divided the miles by 2 and got 50. Now that we just discussed it and you thought about it, answer this question. How do we know that at 1 hour they would have traveled 50 miles? Okay, now here's some new information. On this train, the dinner service, on which they serve the kids dinner, starts once the train is 250 miles away from Yonkers. What is the minimum time the players will have to wait before they can have their meal? Okay, 250 miles away from Yonkers is when the dinner service starts. We don't have 250 miles on our table. So this time we're going to use our information and plot it on a grid to see if we can find out where 250 miles will be in terms of time. And I'm going to take each of my set of values and start making coordinate points. So 2 hours to 100 miles would be an x coordinate of 2 and a y coordinate of 100. The reason I'm using hours for x is because time on a grid will always go on the x-axis. And if 2 and 100 was a coordinate point, then simply put, the rest would just be pulling that data over and making ordered pairs all the way down. And again, I'm labeling my x-axis in time, hours, and the y-axis in miles. And I'm going to space my hours out by 2 because if I look at my hours column, they are jumping by 2. And I'm going to space my miles out by hundreds because if I look at my miles column, they are in 100 jumps. And so I need to start plotting. Let's use our first set of data. 2 hours and 100 miles. So to plot this point, I go to 2 hours and I go up until I hit 100 miles and I put my point. And I'll do the same for 4 hours and 200 miles. And I'll do the same for 6 hours and 300 miles, going from 6 hours up to 300 miles. And I just keep repeating this until I've plot all, 5 coordinate points. Now, if my coordinate points are in a straight line, and they are in this case, then we should draw a line through them. And now we should be able to answer the question, at 250 miles, what would be the amount of time they would have to wait? Well, 250 miles would be right here. So let's label that point 250. And if I look across until I hit the line, I will hit the line right here. And this is important because now all I need to do is follow it down to the x-axis and see that I am at a spot between 4 and 6 hours. In fact, I'm exactly halfway between 4 and 6, which would be 5. So the question is, what is the minimum amount of time that the players would have to wait before they can have their meals? We've found that the minimum amount of time they'd have to wait before eating is 5 hours. And so to sum all of this up, guys, a ratio table, equation, or double number line can be used to create ordered pairs, which then we can plot onto a grid. For example, if I have this table of values, I can take it, turn all of the values into an x and y coordinates, and then plot those coordinates. This will help me find any other information that I might need along the line that follows between all the coordinate points.